Christmas is coming around, and I have a 4-year-old. And I felt like, what's the coolest thing you could do for a 4-year-old? Build him a front end loader. So anyways, this is the maybe 50% version of that. It's not quite there. And then, you know, the idea was, okay, well, you know, my son has a front end loader. It's got track drive, you know, regular tank drive, old school, right? You know, both of them forward, and then you can spin by, you know, pulling one forward and one back. And then if he gets in trouble, I can, you know, switch over to manual daddy drive. But then, you know, last summer I took the self-driving car for Udacity, and you know, the project that really fascinated me in that series was the behavioral cloning, right? Where you can, you know, based on what the driver's doing, you can actually start to learn to actually drive, you know, around a racetrack. And I know this is probably not exactly analogous, but maybe the idea would be, okay, well, he's pushing sand around he's got a big sand pit he can use, so I'm going to try to actually take it to that next step, hopefully with some help from my friends, and actually get the robot to learn what my son does. So that's my ultimate goal. But tonight was the first time I had it drive in, so I decided to run over here and show it off real quick. I'm not going to put it on the floor because, you know, demos. Yep, exactly. Yeah, so I didn't calibrate it out exactly. It doesn't calibrate on startup for some reason. So I got to figure that out. So that's manual drive for me, and then for him, like I was saying with the tank drive, both forward, both back, and then you can spin. And I actually just finished that mix code tonight, so that's why I managed to get over here. All right, that's it.
Question. Your 4-year-old gets that?
My wife doesn't know yet.
Get bigger.
Seatbelt.
There's going to be a cage over it. There is a seatbelt. He wears a helmet. He's going to be safe. Believe me, my wife would never let that fly. So, yeah.
What about his legs?
Yeah, well, the intent is, I mean, we're saying 50% of it. So what's going to happen, there's going to be a little cage here. And then I have just like one of those snow shovels, and I'm just going to repurpose it with an actuator, and just so he can just kind of lift it up and down.
What was the build process that you had? When did you start building this?
Actually, this was meant for last Christmas.
Wait, so this was for 3 years?
Well, I reconsidered that because he wasn't quite ready, so I stopped working on it for about 10, 11 months, and then I just recently started thinking, well, you know, if I really want to get this done for this Christmas, I better start really cranking. So, yeah, it takes a long time. I mean, there's a lot, you know, fabrication, and what actually took more time than anything is just wiring up the box. I can fabricate pretty quick, but wiring is actually you always underestimate the wiring.
Any plans to increase the size for adults?
Do I have a market for this?
Maybe. The golf road market's pretty big, you know.
What are those joysticks from?
I use, you know those genie lifts? The ones that are like big scissor lifts, right? From maintenance. You can find surplus. I just got some surplus ones. I only use, you know, maybe 1 or 2 channels off of it. There's a bunch of channels you can use on it.
Yeah, I see you and Wes hanging on it.
Yeah, Wes helped me with that. He helped me figure out which signals to use. Yeah.
Where did you purchase the treads from?
Snowblower. It was surplus snowblowers. And you know, I've looked for replacements and I actually couldn't find any. So what ends up happening is if you look at these things, they have patches all over them. From, you know, I've used them and they break and then I put them together again.
there's another source for treads, and that is conveyor belts.
Oh yeah.
There are
yeah.
modular conveyor belts that snap together. I bought about, I don't know, 20 or 30 feet of them once, and I was going to do a project like that.
Right.
Get it done.
Yeah, that's a good suggestion. Okay, anything else?
Actually, I have a question. So you were saying that you have like a override, so if your sound gets out of control, you can like start remote controlling.
Yeah, so this is just a 3-channel radio.
Okay.
And so 2 channels obviously are for steering and throttle. And then the third one is for switching between manual override and then also just one joystick.
Right. Okay. Cool. So you have a remote control sun from time to time. Very cool.
Closest thing to a robot.
So since this is kind of the Halloween-themed robotics club, I said you could bring, Halloween stuff that you made that actually moves around. So I don't know if you guys seen The Nightmare Before Christmas, but there's a character from it called the Mayor, and so I made him because he's kind of neat. He moves his arm around and also his head. He's a politician, so he spins around. I cut it. It's all made out of styrofoam, and I cut it out of my CNC machine and kind of layered it, put it all together. And in the center is where all the electronics are, and he moves his arms, and the 2 arm motors are from the car doors to make the windows move up and down. They have pretty good torque, so I use them for the arms, and then I have a stepper motor for his head to spin his head around. And yeah, so it's the theme of the house is that. So other attractions. So and I have these other guys too, Bob Truck and Barrel. So let me.
Where's your house?
In Gilroy.
Oh, okay.
So let me start it from here. Give me 1 second. Oh yeah. So actually, sorry. So I have an Arduino in there and a couple H-bridges, that control the motor, and then so there's a little sequence that I play, and it's from a clip from the movie, and so then I send the commands, timed to that sequence to the ESP86 that gets those commands and move head, move arm and things like that, and so it carries it out towards the sequence of that.
Did you manually sequence it?
Yeah. It's pretty basic. So, 1 second.
Jack, you home? Jack, I've got the plans for next Halloween. I need to go over them with you so we can get started. Jack, please, I'm only an elected official here. I can't make decisions by myself. Jack! Answer me! He's not home. Where is he?
He hasn't been home all night.
Oh.
Actually, so what? If you want, do you want to see the actual sequence that it was, or the movie clip?
Yes, please. Sure.
All right, just real quick. Have to show that to you. So you can see what it makes more sense.
Just cut this out if you're worried about copyright
Yeah,
claims.
copyright. It's 60 seconds, so it's okay. Okay. All right, I guess we'll see something. Okay, no sequence, sorry about that.
This is PVC-3. The reason why it's PVC is the main body of it is all PVC. The rest of it's 3D printed, except for the bumper. This is, by the way, this is a robot for the Robo Magellan Challenge at Robo Games. And really, Robo Games has been around for like 15, 16 years. We're hoping it's going to happen again. David always, he's the organizer, always says every year it's not going to happen, and it happens. So it's good. And where does it go? There's our two-time winner in the back, kind of hiding. I think he's transplanted from Germany. Yeah, okay. His robot last year did a super job. It went all the way around the building, found the cones, did just a tremendous thing. So he won the gold last year and the year before. Anyway, this is for the Robo Magellan Challenge. It's got, right now, just two processors. It's got DS-PIC 33 and a PIC 32. And it's all talking CAN bus. It's got 16 ultrasonics that go around, down at the bottom, and around here, and in the back. It's got another one of those cool displays. Let's see if I can power them up here. That I spoke earlier in my other robot, which is the Nexon display, which gives it a lot of different abilities to select different parts of the robot for diagnostics, for running, for giving you information back. It's been around for a number of years, and we're still trying to, you know, a couple of years ago, where's Osman? Osman, he had his Robo Magellan, and you know, like all of us, we don't do the work until the night before or the weekend before. So,
Homebrew style.
Yeah. So Osman comes, and he said, well, the only thing I have is odometry. I don't have any compass, any GPS, anything. And he said, I'm going to run it. So his first run, you have three chances. His first run, yeah, it did okay. So he went back and he made changes in his code. Second time, just on odometry. You go out, turn, come down, make another turn, see if you can find the cone. Got really close. Okay, I'm going to go back. Did some more code real quick. And the third run, he found the cone. And that got me thinking, you know, everybody, we always start, and nothing against all the people out there with Ross and stuff, but we really got to start kind of from the basics. And having good odometry and good navigation on IMU and being able to drive and being able to make turns is really important in this competition. And then being kind of fast helps too. Your robot last year was extremely fast. I think you did it, what, in like 8 seconds or something?
No, that was game time.
That was game time.
Game time, because he touched a 0.1 multiplier.
Right.
The damn bonus cone was in the back of the building.
Yeah, Camp and I were...
Marco Marthal,
yeah. Camp and I were running around trying to make sure everything worked. Anyway, it's a great competition. So they've got all the different competitions. I think we have tabletop. We have challenge at Robo Games. We have
Walker,
balance race, line following, and then there's a whole bunch of battle bots, which I don't do anymore. But so if we have it, we really kind of think about it. And you know, the tabletop challenge, if you've done it here, you can do it there. And let me tell you, the medals that we get, it's like Olympic medals. Are really cool. Right.
You know, the Robo Games is no more. I'm sorry to tell you.
Well, you know, I don't know. I haven't talked to David, so if you don't...
David's made an announcement.
Oh, has he?
Yes.
Oh, okay. All right. So it's not, he's not going to do it.
Sorry.
Anyway.
To our own.
What's that?
Do our own.
We'll do our own. Yeah, I mean, you know, we can certainly do that. So it's got GPS and compass up here and trying to get everything to run. But the display is kind of the new thing that I've added, which makes it kind of easier to do a lot of diagnostics and stuff. So if you have, again, interest in that display, come and see me. So,
what was the name of that display again?
A Nextion. Nextion. And they have all different sizes, up to 7-inch. This is a 7-inch display. And like I said, it makes it, I did one with a regular 7-inch TFT display. I had to do a printed circuit board. It had 20 or 30 connections to it, and it's just a nightmare. This, again, both software and hardware, it's just standard TTL serial power, and then the IDE that they give to you to do all the graphics and stuff is really nice. So it makes life a lot easier. So anyway, there we go. Thank you.
Cool. Thank you.
Okay, so some of you who are regulars have seen me demo robot a number of times, but for others who haven't, basically it's running a Jetson TK1, the very original Jetson. Has a Nito LiDAR, a buck boost power regulator, lithium polymer battery, RoboClaw 7-amp dual motor controller. I'm using a TI ARM4, one of their little eval dev kits to do some of the interfacing. Sure, I can point it out. There's the camera. Zoom in.
Oh, I can't see.
No, you can't. Yes, and then it's a little LCD touch panel display, pair of motors with encoders, so all the usual sort of stuff, but running ROS obviously. But yeah, I thought I'd just mention that for anybody who hasn't seen it already. Katobot.
What are you calling it?
Katobot.
Kato.
K-A-T-O.
I think there were no more hands up for Run What You Brought.
I got one more to bring.
Oh, okay.
You guys aren't bringing enough robots. It's a little after 9, and you need one more. This is Rodney Jr. It's based on a book, How to Build Your Own Self-Programming Robot. The concept is that this robot first, the goal is to either go forward or reverse. With a differential drive system, the only two motion patterns with any magnitude or displacement are forward and reverse. So he monitors this Roomba, I call it a stall detector, to see whether or not it's stalled. So first the robot's going to move in random directions, and then when it discovers a motion pattern with magnitude, you'll see the green light come on, and when it stalls, its reaction is successful, it remembers it. And when it's in that motion pattern and stalls, it tries the successful response. If it continues to be successful, it increments the confidence level. If it's no longer successful, it decrements the confidence level. So eventually, the robot will go to the motion patterns that have magnitude, that being forward or reverse. It's not that the robot goes forward or reverse, it's that it learns to go forward or reverse. This one's beta here. So you'll see him doing random motion patterns initially. When the light's red, he stalls. And when it's green, it's good. He likes it, okay? Now, again, beta is random. It does random motion pattern trying to discover success, okay? If it's successful, it increments confidence. If it's not successful, it decrements the confidence and thereby learns. In the gamma, when it encounters a stall condition for a motion pattern for which it doesn't have a successful response, it goes to other high confidence level responses before reverting back to random responses. So with a little bit, with any kind of luck, we shall see the robot go forward and reverse.
Does it know it's hit the wall and that's a good thing?
No, all it knows is that encoder, and its only goal in life is to have that encoder continuously spin. As long as the encoder is spinning, he's happy. And when the encoder is not spinning, he's not happy. So let me interpret what's happening here. The robot's learned reverse, and it's also got a positive response from the left wheel going reverse. And so he does that. He goes reverse, forward. Oh, now he's going to make a liar out of me. Okay, here he's going forward and reverse. Success, thank you. Next time, bring more robots and you won't have to sit through this again, okay?
I will.
And to those of you who did bring robots, thank you very much. I guess, one last call. Anybody doing run what you brung? Anything at all? No? Going once, going twice? Sold. All right. I guess that'll be meeting adjourned. Cam, does that end the meeting?
Yeah, I hereby declare this 16th annual Phase 3 HBRC challenge to be over. Any objections? So be it. Thank you very much.